Hey everyone, let's talk about hash tables. So what are hash tables? Well, according to noted Google blogger Steve Yagi, hash tables are arguably the single most important data structure known to mankind. You absolutely have to know how they work. Well, why are they so important? Well, to answer that question, we just need to look at this handy dandy chart from bigocheatsheet.com. Now, if you'll notice, hash tables have the coveted property of constant time complexity for search, insertion, and deletion, which no other data structure can match. It's important to know how they work and why they work the way they do, because if you'll notice on the right side, in the worst case, that performance degrades to big O of n, or linear time complexity. And it's important to know how and when and why that degradation occurs. So what are hash tables? Well, you might know them better by some other names, such as associative arrays or dictionaries or objects. In Python, they're called dictionaries, but hash tables are also used to implement the functionality underneath the hood behind objects. They're also used for programs like Memcached, which does HTTP caching, and also for dynamic programming and memoization. So how do hash tables work? Hash tables are basically an implementation of key and value data storage and retrieval. And the way that works is an array is declared. And if you remember from data structures, arrays are blocks of contiguous memory which allow for constant time access. What that means is that each element of an array is right next to each other in memory, which means that if you want to get to the fifth element, all you have to do is multiply 5 times the size of your data, and you can skip right there. A hash table will take a key in any form, usually a string or different things. It runs it through a hash function, which will change that key into an integer. And then that integer is run through a modulo function to make sure that it's within a certain range. In this case, 0 through 15. So John Smith is a string. He gets run through a hash function. It turns into 2. And then the value associated with the John Smith key gets put into this number 2 bucket in our hash array. Same with Lisa Smith. Lisa Smith, the string gets run through the hash function. It becomes 1. And then 1 is where our value is stored. And that's basically it. Now, if we're looking at in pseudocode, the way that's usually expressed is with square brackets. So our hash table, you give it a key, and then you set it equal to a value. And underneath the hood, again, we're finding an index by taking a hash function and running the key through that hash function. We're running it through a modulo of the length of the array. And by array, again, we mean the storage array. And then we're setting the value to the index of that array that we've got from our hash function. Now, again, keep in mind, this is pseudocode. This is not C code, but that's basically all that's going on. Now, what is a hash function? A hash function is a one-way mapping from an arbitrarily sized data to a fixed data size and type. Now, there's different types of hash functions with different attributes. You may have run into hash functions earlier with cryptographic hashing, which is how passwords are stored in databases. So you take a password, maybe password 123, you run it through a hash function, and it turns into some long gibberish string. But every time you run that password through the same hash function, you'll get the same gibberish string. So instead of storing the password in clear text, which is very, very insecure, you can check if the password is correct by just comparing it to the long string. And no matter how many times you run that same password through that same hash function, you will always get the same gibberish string, which is what we mean by deterministic. With the same input and the same function, you'll always get the same output. There's certain other attributes that can be important, such as uniform distribution, which means that an input that's very close to another input will be, on average, very, very far away from the original input. It's non-invertible, which means that you cannot take the result of a hash function and reverse construct the input, which is very important for cryptographic hashes. You should not be able to take the Gibber string and deduce what the password is. And there's also some different traits called continuous versus non-continuous. And that's very close to what we talked about with distribution. These are some traits that you look at when you're determining the validity of a hash function, and different hash functions have different use cases. So, for example, we can look at a very, very, very basic string hash. This algorithm will take all of the ASCII values of a string and add them together, and then run it through modulo of 32, which will give us a string, give us an integer between 0 and 31. So if we were to hash, say, the basic string hello, capital H resolves to 72, lowercase e is 101, L is 108, we do that twice, and O is 111. And if we add those all up, we get 500. And then if we do 500 modulo 32, we get 20. So this is a very, very basic hash function that will turn this key, which is the string hello, into an integer, which is, in this case, 20. For world, we can do the same thing, and we'll get 87, 111, 114, 108, 100, which resolves to 520. And when we modulo that by 32, then we get 8. So again, the purpose of the hash function when it comes to hash tables is to turn an input key into an array index. And since our array is size 32, we want that to be, the index to be between 0 and 31. So how do hash tables work now that we understand hash functions? Well, we declare an array of size, usually the size of power of 2, so it fits nicely in memory. We allocate that much memory using the malloc function in C. So default size in this case is 32, and this we want to declare, we need to do size of the value type. So this is key, value in terms of key value. So let's say, remember in C, since all types are very strict, we want to have keys of type string, and let's say values of type integers. So in this case, we would do malloc of 32 times the size of integer. And then to find out where we're going to store it, we hash the key, which if we're hashing with our basic string hash, hello, will give us 20. And then we store our value, which let's say it's 1,224. And we're going to put that in slot 20 in our array. And that's about it. That's hash tables.